Ever wonder how AI systems stay sharp as the world evolves? Like, how does a recommendation engine know exactly what you'll like next without forgetting what you liked before? It's all about something called knowledge graphs, those massive digital maps of facts, relationships, and connections. But here's the catch. When these graphs grow, traditional AI models struggle. They either forget old info or get overwhelmed by new data. Today, we're diving into a breakthrough solution. Sage, a framework that lets AI learn continuously without losing its memory. Let's start with the basics. A knowledge graph is like a living, breathing encyclopedia. Think of it as a city map, where every building entity is connected by roads, relations. But cities change, new buildings pop up, roads get rerouted, and neighborhoods evolve. Traditional AI models treat this like a static map. When updates come, they either overwrite old data or get stuck in a maze of complexity. It's like trying to redraw a map, while someone keeps adding new streets without telling you. Enter Sage, the flexible architect of knowledge graphs. Instead of a one-size-fits-all approach, Sage reads the scale of each change. Imagine adding a few new streets to a neighborhood versus redesigning the entire city. Sage adjusts its embedding dimensions, the mathematical space where data lives, based on how big the update is. Too small and it can't capture complexity, too big and it slows down. Sage finds the perfect balance, like a chef adjusting the heat while cooking a meal. Here's where it gets smart. Sage uses a technique called dynamic distillation. Think of it as a teacher helping a student learn new material without forgetting old lessons. When new facts arrive, Sage doesn't just cram them in. It balances preserving what's already learned with absorbing the new. This prevents catastrophic forgetting, where learning something new erases previous knowledge. It's like learning a new language without losing your ability to speak the old one. The results? Sage outperforms existing methods by up to 1.6% in accuracy, adapting seamlessly whether the graph is quietly expanding or undergoing a major overhaul. This isn't just about numbers. It's about building AI that's as flexible and resilient as the real world. From e-commerce platforms tracking millions of products to chatbots understanding evolving conversations, Sage's approach ensures knowledge stays relevant without constant retraining. But how do we know Sage works? Let's look at a study comparing it to other methods. Researchers tested their own approach, GraphEqual, against frameworks like Sage, Relation, and specialized datasets like GraphHigher or GraphLower. The results? GraphEqual outperformed all competitors, including Sage, across every metric. How did they measure success? They ran an ablation study, a fancy term for testing what happens when you remove parts of a system. Imagine taking apart a car to see how each engine component affects performance. Here they removed key parts of GraphEqual like scale estimate, SC, difficulty-based sampling, DS, lightweight expansion, LE, and dynamic integration, DI. The table shows how each removal impacted results. For example, when they took out SC, the system's accuracy dropped from an MRR, a measure of how well it ranks correct answers, of 0.28 to 0.268. That might sound small, but in AI terms, it's like losing a crucial gear in a machine. Performance plummets. Similarly, removing LE caused a big drop in handling complex relationships, while stripping DI hurt the system's ability to adapt over time. What's fascinating is that their full method, GraphEqual, consistently beat others across all metrics. On the entity dataset, for instance, it achieved an H@1 score of 0.147, meaning it got the top answer right almost 15% of the time. Compare that to Sage, which lagged behind in every category. But here's the real kicker. The datasets they tested on weren't just static. They included time-sensitive data, like Snapshot 1 to Snapshot 5, showing how the system handles evolving information. GraphEqual stayed strong even as the data grew more complex, while other methods struggled. So what does this mean? It suggests their design isn't just clever, it's robust. By carefully balancing these components, they've created a system that's both accurate and adaptable. And in a world where AI needs to process ever-changing information, that's a big deal. Next time you see a recommendation that feels just right, remember, behind the scenes, frameworks like Sage and GraphEqual are working hard to keep that knowledge fresh, accurate, and always growing. Thanks for watching. What do you think AI should learn next? Drop your ideas below.